Unfortunately, coming into 2026, PC building be like this. And it may only get worse. So in today's video, I'm gonna show you how to transform an ASRock AMD BC-250 crypto mining board into a really cool 1080p gaming PC. We'll be installing custom BIOS and software, modding a heatsink, cutting some wires, 3D printing a custom case, and then putting it to the test. The BC-250 actually uses the same AMD 4700S processor that was found in early PlayStation 5 consoles. It has 6 usable Zen 2 cores, 16 threads, and a base clock of 3.5 GHz, making it surprisingly capable for gaming. But these chips didn't quite meet Sony's quality standards for the PS5, so AMD repurposed them for crypto mining boards. And when the crypto market crashed, these boards flooded the secondhand market for dirt cheap. Unfortunately, supply and demand is a real bleepity bleep, because the more popular these get for budget gaming builds, the higher their price gets. When I got mine a few months back for this project, it was only like 60 bucks. But as of early 2026, unfortunately, they're more in the $150 to $200 price range, which makes them less of a budget build and more of a PC enthusiast DIY project. But a really fun and worthwhile project nonetheless, especially considering the freaking insane prices of PC components right now.
Oh my goodness!
Alright, let's talk about what we're gonna need to turn this into a gaming PC. First being a power supply. Next, you'll need an M.2 NVMe SSD drive. This is one that I had lying around but didn't actually end up using it because, yeah, Windows and BitLocker. If you don't already have a spare, don't go out and buy an expensive one, because the BC-250's M.2 slot is only PCIe Gen 2. So when shopping for one, look specifically for a PCIe Gen 3. And you're obviously going to want a case for this, or you're going to be showing up to your friend's house with this. So I literally spent days and tons of filament designing this case, so hopefully most of you guys like it, but for those of you that don't, it's totally fine. But I am gonna have to cordially invite you to, suck it.
That's funny. Not offensive. Because it's nature, educational.
Nah, just kidding, it's fine. There's lots of other really cool cases out there for the BC-250. But if you want to use this video as a guide, it's probably best that you use the case I designed, because I've designed it with all of these specific components in mind. I'll have all of my STL files available in the link in the description. But if you guys really do like the case and you want to put your own spin on it, please consider becoming a member of the channel. You'll get some cool benefits, including access to my project step files. Next, we'll need a bunch of M2 5mm self-tapping screws. Not 4, not 6, 5. I don't know, that's just what she told me. And now you'll need a latching switch. The one I chose for this project only has 2 leads and it's really easy to wire up. But if you do want one with an LED and can figure out how to wire it up on your own, more power to you. Just make sure you get one that says latching, not momentary, and you want to make sure it has a diameter of 16mm right here. Next, you're going to need this specific Anchor USB hub, a 120 by 120 PC fan, a standard DisplayPort cable, a display that can take that DisplayPort signal, a DisplayPort to HDMI adapter, a USB keyboard and mouse, capped on tape, and we're definitely going to need this. Oh yeah, baby.
What are you doing? Get out, Mom!
Next, you'll need a 32GB or less USB drive, and to avoid issues down the line, make sure it's at least 3.0. You'll also need a Wi-Fi and Bluetooth dongle. I had these laying around and I don't know what they're rated for, but they work just fine. A regular-ish sized Phillips head screwdriver, as well as a smaller one. You'll also need a controller, and I found that these Xbox Series controllers work really well with Bazzite, which is the operating system that we're going to be using. And some things that are technically optional, but I highly recommend: a mini Bluetooth keyboard, a nylon dust filter for your fan intake, and some thermal compound for repasting the APU. Now, before we get too deep into this, we should probably check to see if our BC-250 is actually functional. So let's first take a look down here at this power jumper, and we want to make sure it's in the position that's furthest from the battery. If your BC-250 came with an SSD pre-installed, we're just going to go ahead and remove that for now. Next, we're going to take this 24-pin cable that came with the Apevia PSU, and what we're actually going to do is cut most of these leads off, because most power supplies won't even power on unless they're connected to a full PC. So this is our workaround, and it's going to make more sense in just a second. These are the only 2 wires that we're going to keep. Everything else is dead to us, you know? Unless you have one of the LED switches, or you want to add like RGB lights or something, which of course you'd want to keep some of these other leads for. Now go ahead and pull all those wires away that you just cut. And we're gonna wanna leave some of this excess wire. So like 2 inches should be enough, right? Well, let's actually just cut it all the way up here so we have plenty to work with. Now strip the ends of these 2 wires and strip a little bit more off of the wires on the switch. Now twist the wires together like this. Now, if you guys have a soldering iron, you're obviously going to want to light this joint up, but I'm going to go without just to show you guys that it is possible. Not ideal, but possible. But really only because these joints are going to be shorting 2 pins together and not actually carrying any power. So don't make this a habit. Yeet 'em and delete 'em. Now you're going to grab this other cable that came with your power supply, you'll plug the 8-pin side into your BC-250, then you'll grab this 6-pin connector and plug it into your power supply. Now connect your AC power adapter, your DisplayPort cable, and your USB keyboard. And finally, we'll plug our makeshift power switch into our power supply and see if our BC-250 turns on. Now spam that delete key like your life depends on it. If you have a working BC-250, you should come to this BIOS screen. Dope. Alright you guys, now we're ready to install the modded BIOS, and this might just be the most critical part of the whole project, so follow along closely. First thing we need to do is format our USB drive, so you just find your USB drive in here, make sure this is selected to FAT32, and I'm just gonna rename this to Yo Mama. Yum, kama. Click start, and yes. Wow, don't you just love Windows? Then you're going to find the link in the description of this video called Flashing Tools. Then you're going to go into your downloads folder and find this folder right here, and you are going to extract it. Alright, then you're going to click on this folder right here and then on the BIOS EFI folder. Then you want to put this Robin 5.0 file somewhere safe. I'm going to put it in my desktop. Then you're going to copy the remaining files here and you're going to copy them to the root of your USB drive. Yum, come on. Now you need to go click another link in the description of this video, and it is called Modded BIOS ROM. And then you need to download this one right here. And then right over here, click download. Then you're going to go back to your downloads folder and you need to put this file right here into the root of your USB drive. And you're going to find this file that you just put in there right here, and you're going to rename it to Robin 5.00. And you do not need the file extension. So delete that, then press enter. And yes. And now your USB drive should look like this. Now eject your USB drive and let's go put it in the BC-250. Turn your device on and wait until you see this screen with the yellow text. From here, type this BLK0 command, and it's really important here to make sure that you add the space after the colon. Press enter. Now you'll type this command. Now we're going to hit the enter key again, and then we are going to wait. Don't touch the keyboard, don't power off your device, just wait. Because powering it off now will give you a freaking brick. Ah, freaking Packer, get out of here, this is too important. But seriously, just wait a little bit. When mine was done, the screen went black, and I'm not gonna lie, I was a little scared, so I waited like 30 minutes just to be safe. Now turn your BC-250 off and remove the USB drive. We'll now clear our CMOS by removing this coin cell battery for at least 90 seconds. And after we reinstall it, we're gonna turn on our BC-250 and spam the delete key again, which will bring us into our new modded BIOS. And to get the best performance out of our BC-250, we are gonna make some changes. Let's use our right arrow key to get to the chipset tab, then enter to get into GFX configuration. Set integrated graphics controller to forces and hit enter. Set UMA mode to UMA specified. Set UMA frame buffer size to 512 megabytes. Now you'll hit the escape key to go back, then your left arrow key to get to the advanced tab, where you'll go down and hit enter to get into CPU configuration. And make sure that IOMMU is set to disabled. Now you'll press F10 on your keyboard and yes to save.
We did it! Yeah!
Now that we have those BIOS settings changed, we are going to repaste our thermal compound. Now this is technically optional, but I did it and I really think that you guys should do it because who even knows what these boards have been through, and they might be pretty crusty. To do this, we're going to start by taking out these 4 screws on the bottom of our BC-250, and then separating the heatsink from the motherboard. As you can see, there's lots of thermal paste and thermal pads on a lot of these components, and mine was pretty crusty, so I was glad that I did this. We're going to use paper towels and IPA to clean off all of the old stuff, and normally I would use Q-tips for this, but I was fresh out. Once I had most of that cleaned off, I reapplied the thermal pads and the thermal compound. Too much thermal compound? I hardly know her. Okay, pause. Future Spencer here. I am an idiot because when I went to do some performance testing later, I was getting pretty high temps on the APU, and then realized I was using super old thermal compound, and I had to redo it with some PTM 7950. So lesson learned, don't cheap out on this. Alright, unpause. Now we'll reinstall the heatsink by getting it into position on top of the mother packer. Dang it, not like that. Jeez. Alright, so I actually failed to get this on film, but this back panel here, you're also going to want to take this off and do that same repaste process. The RAM chips are located on the back, and you might as well do it while you have everything out. Alright, as you're tightening up these screws, don't tighten them all up right away. Instead, do a couple rotations on each screw until they're tight. This will help your thermal compound spread more evenly. Alright, now that that's out of the way, we can install our M.2 drive as well as Bazzite. For those of you that haven't heard of Bazzite, basically all you need to know is that it's a fantastic Linux-based operating system that works great for playing PC games. If you've watched any of my other videos, you know that I am a huge fan of Bazzite, and I've made some other videos talking about it. So if you want to know more, go check out this video, but full disclosure, I let the intro get a little bit out of control. Cause you're my little pony now, boy. Oh no. Yeah, it got a little crazy, but if you guys do end up going and watching it, let me know what you think in the comments. Alright, back on track. To install Bazzite, first we need to set up a USB drive. Alright, let's go up in this top right corner and select download Bazzite. And then right here, you're gonna select desktop. Then right here, you're gonna go with this AMD RX. And right here, you're gonna select KDE. And then right here, this is up to you, but honestly, you're probably going to want this option right here. You want to load right into Steam gaming mode. Then you're going to go right here and select download Bazzite deck. And this is going to download the ISO that we're going to need to flash onto our USB drive. And once that's done downloading, you need to open your flashing software, which you could use Balena Etcher, Rufus. I'm going to be using Balena Etcher. And you're just going to click on Flash from File, and you're going to find your ISO right here. Then you're going to select your USB drive. And then you're going to click flash. And once that's finished, you're going to eject it from your PC and go put it in your BC-250. And you might as well go ahead and put your Wi-Fi and Bluetooth dongles in as well. Now turn on the power and wait for a little bit, and you should get this screen. This is a live ISO, and you're going to want to click install Bazzite. Now choose which country you live in, your time zone, and which drive you want Bazzite to be installed on. Encryption? Nah. Now you'll make a Bazzite user account and start the install process. Now this usually only takes like 10 minutes, but depending on your drive speeds, it can take a little while, so just be patient. Once it's finished, you're going to turn your BC-250 off, remove your USB drive, and then turn your BC-250 back on. And this startup process will take a little bit longer on this first time, but it'll eventually bring you to this screen. And it's really straightforward from here. You'll input your language and time zone, then connect to your Wi-Fi and log into your Steam account. And now Bazzite is all installed. But before we're ready to go actually play some games, we need to install a GPU governor, which is essentially going to allow us to overclock our GPU. And this translates to roughly 30% performance gains, so it's essential. To do this, we're going to go into the desktop mode of Bazzite and then open up our terminal. We'll then add a repository by typing in this command. You'll type in that password that you made earlier, and then you'll type Y. Now to install the governor, you'll type in this command. Once that's finished, you'll reboot your system with this command. Once your system reboots, you're going to go back into desktop mode and then back into the terminal. You'll then enable the governor by inputting this command. And if you want to check it to make sure it worked, you can input this command. Okay, let's talk about the case. I designed it with a 256 cubed build volume in mind because that's more or less the standard these days. So I am sorry if you guys have a smaller printer. The case is pretty simple. There's these two frame pieces, a mount for the 120 fan, mounts for the USB hub, a front panel, 4 small panels, and 4 larger panels. I have these more plain panels that are easily customizable through slicer settings, but more on that shortly. Then I have these geometric looking panels, which are the ones that I'm using in my final build. Now guys, I mentioned this earlier, but just a reminder, all of my STL files will be in the description, but if you want to make edits of your own to the case, step files make that really simple if you have some 3D design experience. And I will have my step files available to channel members. It's only $3 to become a member, and it really helps support the channel. But at the very least guys, please go and join my Discord channel. I really want to help create a community where we can nerd out about this type of stuff and help answer each other's questions. I've designed all of the case parts so that you don't need supports. For the 2 frame pieces, you want them in this orientation. And I'd recommend at least 4 wall loops, as these are where most of the structural strength is needed. You'll also need the fan mount and 2 USB hub mounts. If you want the customizable panels, you'll need to change some slicer settings. I'm using Orca Slicer, but these settings should be named something similar if your slicer has the option. First, make sure advanced settings is toggled on. Then you need to change wall loops to 6 and change the top and bottom shell layers to 0. Now you can take a look at which infill patterns your slicer offers. I thought triangles, gyroid, and hexagon looked the coolest. This fill multi-line setting adjusts how thick the infill structure is, and you can adjust the sparse infill setting percentage and other settings until you find something that you think looks cool. If you want the panels that I'm using in my final build, it's really similar to what we just did, but keep in mind that you'll need a printer that can do multicolored prints if you want the full effect. You'll also need to set up a multi-height process print, which I'll show you how to do right now. You'll use those same settings that I just showed you, and you'll right click on the model. Select height range modifier, click over here on range, and you're going to input 2.8 to 3.8. Now change the wall loops to 2 and the top and bottom layers to 4, and you should be getting this look. Then to get the multicolor effect, you'll select a height range that colors these triangles a different color. I used PLA for all of the case parts and have had 0 issues with it getting soft, but if you are worried about it, you can go with something different like PETG that holds up better to heat. Before we get this thing all assembled in our new case, we need to modify our heatsink. Basically, we need to open up these fins in this area here so that our fan can pull outside air into the heatsink and then out of each side. And yeah, I'm gonna be honest, this was really tedious and I really struggled. I tried many different methods and eventually ended up folding them down like this with these small pliers. But soon after I finished, I saw this video online doing it this way, and it looks like it works pretty well, so this is probably the way you should do it, because it looks like it'll cause less air resistance, which we'll talk more about later. So huge thanks to this guy, you are a gentleman and a scholar. Once you've finished with the heatsink, you can take these mounts off. You won't need any of it except for the small screw next to the display port. And now it's time to get everything assembled in the case. As you can see, I filmed this before my final panel design changes, but the assembly process will be the same. You'll start with the smaller of the 2 frame pieces and the USB hub. Bring the USB cable through this hole right here, then slide this end of the BC-250 in these slots right here, making sure the USB cable is still in this slot. Then take that little screw from the display port and screw it in. Take the larger frame piece and slide it on, making sure the board fits into the slots. The 4 corners should come together, and you'll use 2 M2 5mm self-tapping screws per corner. Now secure the USB hub with these mounts. And you may notice that I'm doing this in a different order from the video, but just trust me, this is the way. We need to detach our power switch temporarily so we can secure it to the case. You'll unscrew this nut and then screw the switch onto the case like this. Now slide the power supply right here and use the screws that came with it to secure it. Connect your fan cable right here, take the fan mount and nylon dust filter if you have it, and connect them all to these mounts on the case with the screws that came with the fan. Now connect the power cable to the board, reattach the power switch, tidy up any loose cables to your heart's content, and start attaching the side panels. And guys, make sure you don't over tighten these screws. You should be able to see and feel when it's just right.
That's what she said. Ta freaking da.
Okay, before we get too far into performance, I have to admit that I jumped the gun a little bit with gameplay testing when filming. I took this gameplay footage before most of the case and fan placement optimization, so I was getting pretty rough temps on the APU. And this is actually what made me realize that the thermal paste I used was probably more crusty than what was on there before I replaced it. The temps are significantly better now with the new thermal paste and case optimizations. Alright, let's put this thing through its paces. All of this testing is going to be in 1080p, and keep in mind we'll be testing very demanding PC games. Most older games are going to run significantly better. I also won't be testing any emulation in this video, but from what I've seen, it can run systems up to the PS3 and Wii U, so this also makes a great emulation machine. Okay, so Cyberpunk 2077's performance kinda blew me away. We're at high settings, FSR set to quality, and we're getting pretty high frame rates with an average of around like 80. That being said, the frame rates are kind of all over the place, and to make this a better experience overall, I'd probably cap the frame rate at 60, unless you have a display that supports VRR. With Spider-Man Remastered, we have FSR 3 and FrameGen enabled, high settings, and we're getting a solid 60. My capture card isn't really doing a great job at doing these games justice, but this is actually running really well and looks really good. I wasn't quite able to get a solid 60 FPS with Palworld, but with a mix of medium to high settings, this is actually really playable. This can honestly be kind of a clunky game to run, so I'm actually pretty impressed with this. In Red Dead 2, we're getting a mostly solid 60 FPS with FSR set to quality and a mix of medium to high settings. Now there is some occasional stuttering, but nothing too crazy, and you could lower the settings to get things to run a little smoother. And again, my capture card really didn't do a great job because these games look really good. Elden Ring. Straight up guys, Elden Ring, at least the experience I had, was not great. I honestly don't know what was going on. I messed with the settings a ton, but the best I was able to get was high settings at a locked 30 FPS. I could not for the life of me get 60 FPS, even with low settings at 720p. So let me know in the comments if you're able to get Elden Ring to perform better than I did. One big thing I want to note about performance on the BC-250 is lossless scaling. It's kind of out of the scope of this video, but it can really push those games that are kind of like on the borderline with frame rates over the edge to being a great experience. So look more into that, as well as Decky Loader. It's some really cool stuff. So obviously this isn't like top of the line gaming performance, but if you keep your expectations under control, and if you keep in mind that this is an old crypto mining blade, it has an integrated GPU, and it would otherwise be e-waste, this is actually a pretty sweet little 1080p gaming rig. Alright, so I have a confession. I am basically an idiot. And what I mean by that is I'm stupid. Nah, just kidding. What I really mean by that is that I honestly wouldn't be able to do most of these projects without the amazing communities and people behind them. So huge shout out to all of those people smarter than me and their amazing work. Peace out, guys.